Can anybody name this? Sputnik. You are correct. Any guesses on when it was launched?
1963.
Nope. Guess 63 wasn't too bad for a guess. But 57. Yes. 57. It went up in 1957, and it's still up there. And all it was sending back was a little beep, beep, beep. It was just making beeping noise. But Russia scared the crap out of us with this thing because they got up to space first before we did. And we thought, uh-oh, if they were able to control space, then we would be in deep trouble because they could hover things like way up above our country that we couldn't even get to. And they could like launch death rays on us and all kinds of stuff. So it made us really nervous. So we kicked into gear and spent tons of money on science, education and stuff. And we also started working towards getting a man on the moon. But anyway, this was a big catalyst to a lot of space exploration. In 1964, this one went up. There was much more advanced than Sputnik. We put it up there. And 240 years later, it'll still be up there. Just for perspective, you're probably going to die, and then your kids will probably die, and then your kids' kids will live a full life, and they'll die, and then maybe your kids' kids' kids might hear about this thing coming back to Earth. Okay, so it's going to be up there for a long time. So when you put something up there, you say, there's a saying, what comes up must come down. But it doesn't have to come down right away, especially when it's orbiting the Earth. Yes? They don't actually bring it down. It just eventually its orbit decays, and it gets lower and lower and lower because the gravity is pulling on it from the Earth, and it gets lower and lower and lower, and eventually it'll come down. So in the meantime, though, there's a lot of junk up there. Now, up by 2008, there were 8,500 items approximately that were up there. A lot of them were junk. Some of them are actual satellites. So there was a space station up there. You know, but there's a lot of stuff that's just junk. Just picture a space walk where the guy's out there repairing something, and he like loses his hammer, and it just drifts off, or his glove, or whatever. Okay, that thing then. It may seem like it's just drifting off gently into space. It's no big deal. It's just floating out there, but it's actually spinning it. They're rotating around the Earth at in extreme speeds, hundreds or even thousands of miles per hour. So if you get hit by a hammer that's going 800 miles an hour, that's going to hurt. So you have to watch out for all that junk. In fact, they track this stuff. They're tracking all of this all the time to know where it is. Because if you send up the space shuttle and it gets hit by 5 pieces of space junk on the way up, it's going to crash. I mean, it can't handle that. Things are going so fast. Some of these things are like the size of a bus. Other things are really small. The average size, they say, is about 1 kilogram, which is 2.2 pounds. And they're traveling at insane speeds. There was a guy named Dr. Kessler, and he got officially given credit for figuring out that the amount of junk that was going to be up there was just going to grow, and it was going to grow kind of exponentially, because what happens when one piece of junk happens to randomly hit another piece of junk? You get many pieces of junk. Yeah, so you had 2 things that hit, and now those 2 things become like 43 things that are now all up there going at different speeds in different directions, and it gets really complicated. In fact, it's gotten so bad that they say it has reached a critical level where it is now not safe to go up into space. I mean, you think of space as there's so much space up there, but there's so much junk flying around that every week they log 13,000 near misses of the junk and the important stuff up there. There's 13,000 times where a piece of junk gets really close to hitting something important like a space shuttle or a satellite or that kind of stuff. So if it gets worse and worse and worse, obviously, if there's 13,000 near misses every week, and the reason that they don't just hit is partially because they can adjust them. They can tell their satellite, okay, move a little bit to the left, and it will, and then the space junk flies past instead of hitting it. So anyway, I thought it'd be cool to graph or do a quadratic on this until I realized that the data for this is only going up exponentially. So this just brings up the point that not every set of data, like how much space junk there is, would work for a quadratic regression. You need something that goes up and then comes back down again. Kind of like Crocs. You remember Crocs? Crocs were really popular for a while back when you were in elementary school, and they were those like shoes that are made out of styrofoam kind of stuff. And they were really popular, and then they just kind of tailed off, and I haven't heard much out of them lately. I think they're still selling stuff, but they obviously have their popularity kind of went way up and then came back down again. So to get quadratic numbers like that, what is something you think will be parabolic, as in it's gone up, but you think it's going to come back down again? To try to keep this simple, maybe you should think in terms of consumer products that you buy now, but you don't think people will buy in the future as much, or you think is going to become popular, but then back off and become kind of go down to nothing. Yes. Okay. All right. So Siri is definitely on the upswing. What would you think would make Siri come back down and become like not as big of a deal, and all of a sudden not many people care about it anymore? Something that's better, maybe? Okay. Yeah, like, do you guys remember the Palm? Okay, the Palm products were really big when they first came out. They had like a lock on the little small thing you hold in your hand that like keeps your schedule. I remember my old principal used to have one, and he always kept his schedule on there, and it was, you know, pretty cool for keeping your schedule. And then Palm just kind of lost it because Apple came in and ate their lunch. You know, they had a schedule plus you could do it the internet plus you could, you know. So anyway, yeah, some things like Siri right now seems really cool, but it might go back down. All right, so let's say that the number of users using Siri in 2011 is, let's say, well, there's 10 million iPhone users. So it right away, well, wait, though, only the brand new iPhones have it. So maybe it's only like 2 million. So we'll go with just 2 for 2 million. Then let's say that by next year, in 2012, it's going to be more people because they're going to sell more phones, and maybe they extend Siri or to the iPads that they're selling. So maybe it jumps up to like 15 million. And let's say by 2013, they extend it as an app to all their phones that they sell, and so by then maybe it's up to like 28 million. And then let's say that it starts to crest and come back down again because something cooler is out there. So by the year 2020, let's say it's down to only 2 million people are using it because it's kind of neato old school to be using Siri. Anyway, so there's our numbers, and it's really small data set. It's not going to be great, but I just want to test and see if you know how to put the numbers in to your calculator to get a quadratic regression. By the way, if we tell you you must use x equals 0 to be the year 2000, then you'd not want to enter this. You'd want to enter just 11 would be 2, and 12 would be 15, etc. Yes, please do that, because I want to get you used to not just typing in whichever you see on the chart. You sometimes have to adjust it and then put it in. So put those numbers in. We'll see if you can do a quadratic regression. If you need a calculator, please come and borrow one. Don't just sit there. I have a couple of backups. Okay, thank you. There you go. Okay, so for those that have forgotten, you go to Stat, and then under Stat, you're at Edit, and you go to your List 1 and your List 2, and I'm going to delete, delete, delete a few times to get my data out of there. I would not use Clear because I've had a lot of kids lose their whole List 1, and it just disappears, and that's stressful. Okay, 11, 12, 13, and then 20. I don't know how you can add a list in there. I'm sure there's a way. I usually do the memory reset to get it back, yeah. Okay, L2. I need 2 here, and 15, and then 28, and then 2. Okay, and then I go stat, arrow over to calculate. The 5th one down is a quadratic regression, and then I hit, oh, you know what? I'm going to teach you one more thing. I know you already hit enter, enter, but let me show you something cool that you can do with this. All right, so get back to this spot. Do the stat, calculate, quadrag, but don't hit enter. And just let me show you something. If you go like this, if you say L1, and how do I get L1 up? It's under lists, which is right above stat, right? So you go second list, L1, comma, and then you go to list again, second list, L2 is the second one. That's not the cool part, because if you just hit enter, it'll automatically know that. But here's the cool part. You put one more comma, and then this is the tricky part. Got to find vars. Do you know what vars stands for? Variables. And it's right here. I go to vars, and I want y vars functions y1. That was under vars, y vars functions y1. Now why do I care? Because when I hit enter now, it gives me the same exact thing as it gave me before, but it did something cool. Take a guess what it just did. It just put it into y1 on your graphing part of your calculator. Go over to y equals, see it? It's right there with all of its decimals, not rounded even. So it would have been a real pain in the butt to enter that in there if you had to do it yourself. And why is that cool? Because now I can just hit graph, and it'll graph my data. And my window is not good, so I'm going to do zoom fit. How about a zoom 0? And now there's my parabola for it, and my window still isn't great. Let me go to window. Let me move over a little bit. My Y max is only 16. I want it to be like 50 or something. Okay, graph. Anyway, that puts this into your Y equals, and so if you wanted to graph it, it's easier. You could have just typed it all by hand if you'd written it down. You could have then rewritten it and typed it. It just saves you a lot of time. All right, one more thing. Do you know how to plot the data that we just had? You know the data points that we had? You can plot them. Let me show you. Go up to plot, plot 1, hit enter. And I want to actually adjust that. I go second stat plot, and the plot is on, and I can have my L1 and my L2 in there. And I want it to just be dots, so the type is good. List 1. X list is the L1s, Y list is the L2s. They have little boxes. I hit graph. And now on my graph, dang, my window is awful. I need to get a better window. See if that helps me. At least I can see the thing going down. I think it's going down too far, so I'm going to, my Y min does not need to be 1300. Holy cow. Let's make it negative 50. There we go. Now I got my little points on there, and it shows my parabola going right through those little points. Okay? All right, so anyway, I'm just showing you a little more advanced stuff. You do not have to do all of that on the test, but I wanted to, some of the teachers have showed their kids how to do that. I didn't want you to have not ever seen it before. So, all right, so again, that was under stat, calculate, quadrag, and then this is the part where you'd put in L1, comma, L2, comma, the Y1, and the Y1 was under the vars. Okay, Good enough. How many of you feel comfortable with the quadratic thing, getting those equations? That's going to be an easy part. Good. Then let's look at a few more things to see if you're ready for this. Why is vertex form so nice? Because it's got the vertex in it, and that automatically then tells you what other thing? The axis of symmetry. So what would the axis of symmetry be on this one? X equals 5. You wouldn't just say 5, you'd say x equals 5. All right, here's a new completing the square you haven't tried before. It's pretty easy. Let's make sure you're good at one last one of those. And then I'm going to show you a neato way to check it. So here's a real typical scenario. You just got done goofing up one of your R3s. You know you can't figure the stupid thing out. You know you can't get it right. Well, you still could get an A on the test, right? If one bad R3. But now your other three R3s, if you don't get at least one of those right, or sorry, if you don't get all of them right, you're going to drop a grade for each one you get wrong. If you get only 2 right, now you can only get a B. If you only get 1 right, now you're back into the C category. So it will matter, and if you want to check yourself on these, it's not hard to do. All right, so here's what you should do in the first place. It's supposed to be x plus a box minus a box minus 11. Then this part right here, I factor. 12 comes out. I get x squared plus 2x plus box minus 11. Then, where is the most common mistake made? Not taking the 12 and putting it over here. You are correct. And then half and square is another common mistake. Half of the 2 is 1. 1 squared is 1. It's pretty easy this time. And then y equals 12 parentheses x plus 1 squared. And then that and that together make a total of negative what? 23, I believe. Raise your hand if you had that one right. Okay, good. Then, how do you check yourself? Do you remember the quadratic formula? Do you remember that in the quadratic formula, this part right here was called the discriminant, and it told you how many solutions there would be. That was something you learned in higher algebra. At the same time, I talked to my kids about how this was something special too. That tells you the vertex. So if you can remember the quadratic formula, this part of it right here, x equals negative b over 2a, excuse me, this is really important. X equals negative b over 2a, that part right there, that tells you the vertex. Well, wait a minute. What do we do this plus box minus box thing for? It also gives us the vertex. So we can use this to check ourselves. X equals negative b over 2a. Watch how it works. So if x equals negative b over 2a, and if negative b would be negative 24 over 2 times a, which is 12, and that would be negative 24 over 24, which would be negative 1. What did I just figure out? That the x of my vertex would be negative 1. Look at that. See? Negative 1 is what we got, too. That's a way to check yourself, to make sure you did it right. Then, what if you want to check the other part? The other part is negative 23. That's the y. If I stick in this negative 1, okay, sorry, I got distracted there. I'm back with you. If I wanted to get the other score, the other number, the negative 23 part right there, I can get that by sticking the negative 1 into the equation. If I stick in a negative 1 right here, if I stick in a negative 1 right here, and I multiply it all out, it gives me negative 23. Do you have to do that? No. If I were you, I would check to make sure that I did it right by using the negative b over 2a thing. I'd at least do this part. And if I got a different one, it keeps you from making a dumb mistake. Like, what if this was really supposed to be a minus right here? And it would keep you from making that, like, one dumb little mistake. Just a quick little check. The negative b over 2a thing will be smart. But in this case, it wasn't wrong. I would just verified I was right. Okay, so I don't think do you need to do any more of these, or are you totally good at these? I think you're good. All right, good. Point slope. Just write down the formula for me. If you know the formula, I'm sure you can get these right. Y minus. Verify for yourself that you know the formula. Y minus y sub 1 equals m times x minus x sub 1. Raise your hand if you had that one right. Good. Then what's the very first step? You find the slope. Once you found the slope, we just take this minus this, those are the y's, over this minus this. Then you got the slope, and you put it here, and you take any point you want, and you put it there and there. You pick either of the 2 points to do that. All right, good enough. How about this guy? He needs a different formula. Y equals, try to remember it, write it down. It's the big formula for that kind, where you have a vertex and another point on the parabola. Okay, did you have A, oops, A, and then x minus h squared plus k? Raise your hand if you had that right. Okay, good. The vertex of it goes here. What's that? Any other point? Not the vertex, though. Okay, next thing. Ooh, wait, done with that? Yes, we're done. That's what you need to know. Okay, what I would do if I were you is finish the packet if you haven't already, check the packet if you haven't already, look over your notes if you haven't already, and you could watch old videos. Those are some options for studying for tonight. You can also make up your own parabolas and then try to write the equation for it. You know, let's put some dots on a graph. Try to figure out what the equation would be for it. And you could try to do any 2 dots that go a straight line through that. You could try to figure out the line for that. So anyway, you can kind of test yourself on these fairly easy. All right, so test is tomorrow. I'd like to see lots of A's. And that's all I got for you for today.